Hello, happy Halloween, welcome to the video. Today I'll be showing you why DOTween is the best extension for Unity. So let's get straight stuck into it, eh? Okay, welcome. So I've got a bit of a nerd boner today because I'm showcasing DOTween. What it does is it assists you in animating your objects. So if you want to go from point A to point B, what happens in between those two things can be handled by DOTween. So you might just want to send it across from A to B on a linear path. You might want to curve it. You might want to scale it. DOTween can help with that, and it is absolutely my favorite add-on in Unity. So let's get stuck in. To download it, just head over to the DOTween asset store and just add it to my assets. If you've already got it, obviously you can just open it up in Unity. Once you've actually installed it once, from here you can just go straight to your package manager and just search like DOTween. And I've actually bought the Pro version, but I'm not going to be using that today, just the normal regular version. Import it. I've already imported it, but I'll do it again. All right, so once it's installed, just go to the DOTween utility panel, click Setup DOTween, and in here you'll be able to add or remove your modules to make it leaner on compile time. I personally always disable the physics because I never use the tweening physics. I always just use the transform physics, but that's up to you. So click apply. Oh, and also down the bottom here, if you've got the Pro version, you can add additional tweening to things like TextMesh Pro, for example. Okay, so what I've got here is a nice little scene, and what we're going to do is just learn the basics of DOTween. So first, let's move these shapes across here. So they're sitting at 0 on the X. Let's move them across to 10 on the X. Okay. And the shape itself is just this parent object, and it's got these two shapes in it, the outer and the middle one, and then the actual main shape has this shape script on it. So let's open up the shape script. As you can see, we've got the two references to those inner shapes. And let's move the parent object. So transform.doMove. Now, every method of DOTween starts with the do directive. Okay, so that makes it nice and easy. We'll say doMove, and it's saying what is your end value. Our start value is where we're currently sitting at when we start this tween. So let's give it the end value, which will be 10 on the X, 0 on the Y, 0 on the Z. The duration will be, let's say 2. Actually, let's not say 2. Let's serialize a field here called cycle length, and let's set this to 2 seconds, and let's use that there instead. And that is actually all you need to make this tween, right? So let's go across and try that out. Beautiful. And as you can see, DOTween is actually adding a little bit of easing to it. It's starting fast and it's ending nice and smooth though. And we can actually override that ease by saying set ease here. And we can do ease type, and as you can see, there are heaps of eases here that we can choose. And the ones that say just in at the start means the ease is being applied at the start, out at the end, and then in, out, both start and end. So let's just, let's try in bounce, for example. And you can see how much of a drastic change a bounce will have. Like that, bounces, pretty cool. But obviously that's not going to suit us very well. So let's do in-out sign. I think that's always a nice one. And then it would be nice if we were sending it across and then back again and kind of repeating, wouldn't it? So we can actually chain another method here. And by the way, this is called method chaining. So let's chain another thing. Let's say set loops. It's asking how many loops we'd like. Let's say infinite amount of loops, so -1. And then we're asking for the loop type, which we should use yo-yo here, right? Because yo-yo will go from one side to the next, and then it will now use the start position as the goal, and it will reset it, and then go back and forth, back and forth. So let's try that out. Press play, cross, and back again. And it's that easy to set up these tweening with DOTween. So next, let's actually have this middle shape here spinning around. So let's grab the reference to our inner shape And instead of saying do move, let's do rotate. And let's say we'll do a full revolution. So new vector 3, 0, 360 and 0. And then instead of the full cycle time, let's actually do cycle time divided by 2. So let's make it go pretty fast. A little hot tip, by the way, instead of, if you can, always multiply instead of divide. It's a much faster operation. Obviously the computer can do like countless of these every frame, but you know, always be as optimized as possible. And we want this to continuously loop. So let's do set loops -1, and instead of using yo-yo here, we want it to just keep going around the same way, don't we? So let's do loop type restart. And then also let's kind of just have it going at a nice even pace all the time. So let's set ease and let's use linear. There we go. So let's try out this. Aha, nothing happened. And that is because we are saying we want to rotate to this new degrees. So in the backend, this is actually turning this into a quaternion. I say quaternion differently every time, so bear with me. But it's turning it into a quaternion, which is actually exactly the same as our start position. Oh God, this thing. Exactly the same as our start position, isn't it? So it's not actually needing to do anything. We're already at our goal position. So we can fix that by saying, instead of rotating to this rotation, I want you to rotate by this amount of rotation. So we can change the rotate mode here to fast beyond 360. So that will say, whatever you're at now, rotate another 360 degrees. And obviously we're looping, so it's just going to continuously go and go and go. Very cool, very easy. Let's do something a little bit cooler now. Let's take the outer shape and let's rotate that like that. And then let's have this middle shape kind of like going up and down like this. So let's start it at like 3 on the Y. And then let's grab our inner shape here, inner shape, do move. And let's send this to new vector 3, 0 on the X, -3 on the Y, 0 on the Z, and then the cycle length, let's also do it half the cycle length, so divided by 2. And then we could probably just use these loops here. Same loop, same repeat. Let's try that. Let's see what that does. Aha, so it's moving to world coordinates, and that's not really what we want, is it? We want to do local movement according to our parents' position. So we can just do local move, as easy as that. Let's try that out. Excellent, super, super duper easy. All right, so that's the basics of DOTween. Okay, so you set up a tween and then you can just like chain these additional things on there. There are heaps, but these are just like, you know, 2 of them, set ease, set loops, but you'll learn more as we go on. So let's continue. DOTween number 2. So I've got these weird looking blobs here. What I would like to do to them is send them across one by one, and then once they're all across, let's scale them down into 0, okay, and get rid of them. So let's open my weird shape manager, and I've got my reference to those 3 shapes here. So I'll show you it this way first. So shapes, the first shape in the array, let's do move, and because we're only moving on the X, we don't care about the other ones. Let's just say do move X, and the end value will be 10. Duration will be, let's make this a little bit exciting by doing a random value between 1F and 2F. And okay, so now we want to do shape 1 index, right? But we don't want to do that until this one is finished. So how do we do that? Well, we can chain onto this and say on complete, right? So what do you want to do when this tween is complete? What function would you like to run? So we're just going to give it an anonymous function here. And now we can take this exact thing here, but instead say shape 1, and then on here, we want to do the next one, right? So we can do on complete, onto the next one. And as you can see, this is getting a little bit messy, right? A little bit convoluted, but this works perfectly. Like this does the job. Let's try it out. So this one will go, and then that one will go, and then Bob's your uncle, that one will go. Beautiful. And then now we want to scale them, don't we? So what can we do? Well, we can now do another on chain here. And then here we would just like them to all go at the same time. So we can just say for each shapes, and we'll say shape, do scale. And we want to say down to 0 because we want them to disappear, maybe 0.5. And it might be cool if they kind of like bounce down, right? So let's set an ease here and then in bounce. And let's try that out. 1, 2, 3, and bounce away. So that works, right? But this is a disaster, right? It's pretty disgusting. It's very hard to read at a glance. And actually, it's kind of reminding me of old school JavaScript before we had async, and we're kind of like chaining all of our API requests one after another, which probably triggered a few people. But so this is the exact reason why sequences are around. So let's create a sequence, .tween.sequence. Excellent. And now with this sequence, we can kind of like orchestrate all of our tweens. Golly. So let's iterate over our shapes, and we can say sequence dot append, right? So this will always add it to the end of the list, and we can actually send in a tween here, just like that. And obviously we don't want to use shape 0 every time. We want to use the iterated shape. And the thing about sequences is you don't actually have to manually start this. As soon as it goes out of scope here, just like an iDisposable, it will actually action it and it will run the sequence for you. So that's handy dandy. So as you can see, this will now go 1, 2, 3. So much cleaner than chaining them, as you can see. And now, just as we called onComplete on the tween itself, we can now call onComplete on the sequence. So sequence onComplete, right? And then we can actually grab these and do that in the exact same way, just like that. And that will have the same behavior. 1, 2, 3, and bounce out. Excellent. So sequences are great, right? It solves a problem. But if you were watching my async workflow video from the other day, you're probably wondering, is there a better way? Can we use async for this? And yes, indeed we can. And you probably guessed that by this little giveaway here. But let's comment out these. Whoa, not delete them. And open this puppy up. And let's uncomment that. So let's run this async baby function. So as you can see here, we're iterating our shapes and we are now able to await the tween. And we can do that by appending this chain method here, async wait for completion. We can now await it. So as you can guess, it's going to go exactly as we all expect. Excellent. So that's how you can now turn DOTween into an asynchronous workflow. So let's comment out that. And instead, let's run this function down here, tasks. So what am I doing here? I'm creating a list of tasks. I'm iterating over them and I'm adding them all to the task list. I'm not awaiting them, right? So I'm not doing what I was doing up here. I'm just letting them all go. And then I'm waiting for them all to finish. Once they're all finished, I'm then iterating over them and I'm scaling them. So now I'm using an async workflow to handle all of my tweens, which in my opinion is much cleaner. Obviously everyone's got their own preference, right? Some people like to use coroutines over async. You might like to just use the sequences or just chaining them. So, and really I use this too sometimes. Like if there's nothing else relying on a tween or something that has to happen after a tween, I'll just use onComplete. Or if like the method isn't an async workflow method, I'll just use onComplete. It's perfectly fine, just use the best tool for the job. Okay, so the last one is just a few features that I would like to brush over. So here we've got a jump function. Okay, so this is do jump. If I click it, you'll see that it does a jump. So let me show you what that is like. So I've got a reference to my jumper here and I'm just saying do jump jump to this place with this jump power. So how high do you want to jump? Number of jumps 1, and then you can also set the ease on it. And as I'm saying to jump to this location and I'm already there, if I press it again, it's just going to keep jumping there. There's shake here. So basically what I'm doing is I am taking my transform, my shaker, I'm shaking the position, rotation and scale, and it kind of gives it like a little bit of a jello feel. One thing to keep note is that when you press shake, when you start these, it's actually using the current position. So if you start it halfway through another shake, you'll see that it can start to get really out of whack. But one thing to fix that is you can actually cache your tween like this. So say you've got this, say this is like a global method up here. So then you could say if my tween is playing, then don't do anything, get out of it. I don't want to do anything until my tween is finished. And also, if you're about to destroy an object and it's actually got a tween running on it, you can say transform.doKill, and it will kill all the tweens that are currently running before you destroy it. Because DOTween has a safe mode, so it won't actually throw any crazy errors, but it will actually keep trying to access the transform if a tween is active. So always kill your tweens before you destroy the object. Do punch is punching a position, and I'll show you the code. So just puncher, do punch, and this is local space, so I'm saying punch 2 to the left. You can add some vibration and some elasticity to it, but then as you can see, my target is shaking, and I'm doing that at the right time by saying, all right, this is my duration of the punch. I'm setting a delay on this shake of the target by half the duration of the punch. So bam, bam, like pretty easy. So yeah, easy way. That's another chaining method, really important one, set delay. And the last one here, change. When I click it, it just starts changing the material of the mesh renderer's color at random. So this is a reference to the mesh renderer here, material, and I'm changing to a random color every 0.3 seconds. And then on the onComplete method, I'm recursively calling it. So this will just keep changing forever and ever. And I could keep pressing that, and it's now trying to do like a whole bunch of these recursively, poor little computer. So yeah, that's just a few extra functions, and there are heaps of things you can do with it. For example, you can grab your camera and you could tween the field of view or the orthographic size. You could grab your audio source and tween the volume. You could grab your sprite render and change the color. There's so many things you can do with it. And also, just before I let you go, there is just basic float and vector lerpings as well. So you could do DOVirtual float, right? And then you could say from, let's say 0 to, let's say 10 over 3 seconds. This last one here will be the function that you want to do with the value. So let's say it returns a value, and let's make an anonymous function here, and we'll just say print the value. And also, the good thing about this, doing it through DOTween, is now we can actually add an ease to it, right? We could set a bounce to it, and we could also set loops. Right, set loops, whoops, -1, and set that as yo-yo. So that will work as well. And as you can see down the bottom here, it's bouncing up to the thing and then back again. Pretty cool. And actually one last thing before I forget, say you've got a whole bunch of units, right? And they all need to move, and they're all in different areas, but they all need to move to the same location, but you want them to all move at the same speed, right? You would actually need to work out how far away they are from the end result, and then all move at different durations, right? And that sucks. So instead of that, you can actually say, okay, I want you to move. Let's just remove this stuff. And let's just say I want our transform to move across the way to 10 on the X. But now instead of duration, let's say I choose 2 on the duration here. I can say now set SpeedBased, and we'll just say true. So this duration is not actually working as a duration anymore. It's not saying go from here to here in 2 seconds. It's now saying you can move 2 units every second. Does that make sense? So now all your units are all scattered and they're tons of different distances away from the target. They can all move at the same speed as long as you say set SpeedBased equals true. So yeah, so that's moving roughly 2 units every second. Cool bananas. So that's all I wanted to show you. That's DOTween. I mean, it is my favorite library in the whole world. So I hope you enjoyed learning about it. If you already knew about it, I hope I taught you something new. Subscribe if you haven't already. I'll be releasing tons of juicy content. Never in this freaking costume again, because it's been annoying and it's like giving me a headache. But yeah, that's it from me, and I will see you in the next video. Bye.